In this video, we are going to solve a quick example of finding the definite integral as an area. Let's first quickly recall what is the definite integral as an area. Given a function f of x, this is a continuous function and it is also positive on the interval from a to b and a is less than b. The integral of a to b of the function f of x dx is defined to be the area under the graph or the curve of the function f between the point A and B. Now let's visualize that on the graph. So consider we have the xy plane and the interval a to b. Now if we have the function f of x, we define that the integral from a to b of the function f of x is just the area under the graph f of x and the x-axis. So this said region here is the area under the curve, and that is the value of the integral from a to b of the function f of x dx. Okay, let's now go over one example. Interpret the definite integral of the integral from 0 to 4 of the function x to the third power minus 7x squared plus 11x dx in terms of area. We can solve this problem by a few ways. You can solve this by hand, you can solve this by a graphing calculator TI-84, or you can solve this by any other technologies, the software tool. However, we can do this easily by hand by using the power rule, and we can confirm that with the TI-84 graphing calculator after that. Alright, so first thing, let's visualize what is that area look like on the xy plane. Okay, so if we graph this on the xy plane, then we get something like this one here. This is the function f of x, which is x to the third power minus 7x squared plus 11x. And we are looking from the point 0 to 4. So we zoom on from the point 0 on the x-axis until the point 4. And we see that the curve is moving upward, and then it's go to 0 here, and then it go into the negative portion of the y-axis. And therefore, we have the two shaded area. One is above the x-axis, one is below the x-axis. Now, by the definition of the integral, the definite integral of that function is simply just the summation of all the areas from the point A to point B. Now, the area from 0 to the intersection 2.38 is found to be 7.72. This we can find this by using the graphing TI-84 calculator, or you can do that by hand. And then the area of the region here is found to be 5.05. Now, we define that anything above the x-axis is to be positive value, and anything below the x-axis is to be a negative value. Therefore, the integral from 0 to 4 is simply just the summation of these two areas. However, because the second portion, A2, is below the x-axis, we have the minus sign for that instead of the plus sign. So at the end, the whole integral from 0 to 4 is simply just 7.72 for A1, subtract 5.05 for A2, and that should be 2.67 for the overall integral from 0 to 4. Now, that is how we explain the integral in terms of area, but how do we actually solve the problem by the formula, by calculus? Okay, so we can solve this integral by the power rule, and the power rule is saying that we take the power, this is the power function, so this is the power of 3, we add 1 to that, and we divide by the same exponent that we got here, and then we keep the minus sign. We keep the 7 constant in the front, we add 1 to 2, and we divide by the same exponent, and we keep the plus sign, 11, and then this is the first power, so we add 1 to that, and we divide by the same thing. And because we are running from 0 to 4, we are trying to evaluate the answer from 0 to 4 for that interval. And the next step is we are going to make the substitution of 4 to all the places that you see the x. Okay? So we can simplify this further before we make the substitution. 3 plus 1 is 4, 2 plus 1 is 3, and then 2 plus 1 is 3 down here, 1 plus 1 is 2, and 1 plus 1 is 2. And finally, I take 4, the upper limit. I plug into all the value of x here, here, and here. And I subtract, and then I plug in 0 to all the places of x, 0, 0, and 0. And we know that this is 0, 0, 0. They all adding up together to be 0. And then at the end, we just make all the simplification here, and you should end up 2.67. The same thing as we saw earlier right here. Now let's confirm this answer by using the TI graphing calculator 84. So on the TI 84, we can use the function from the math here to find the integral. Alright, so let's go to math. We are going to select option number 9, which is the finite integral. And then all you do is you plug in the correct values here. This is from 0, and then we go up to 4. And then for the function is x, so x is this button here, x to the third power, and then minus 7, x is here, and then square, and plus 11, 11x, and then dx. Don't forget the variable dx here, because we are integrating the whole expression with respect to the value of x here. Then press the enter key. And that is the correct answer that we saw earlier, 2.67, if we round it to 2 decimal places. And that's how we solve this problem and explain that in terms of the area from the function.